Hi everyone, welcome to the channel. So my name is Yukta Bajaj and I am a software developer at Microsoft. And this video is part of a series called DSA course. I am teaching data structure and algorithms course here from scratch. And this video we will be covering merge sort. And if you haven't watched the previous videos, please go and watch them. I've created this channel in collaboration with Newton School. Let me tell you a little something about Newton School. So, guys, Newton School is a platform that will help you accelerate your tech career. You can see Newton School students are already working in very good companies like Unacademy, Shaw, Rapido, and you can see the founder is from IIT Roorkee, and you can see the type of resources they are offering you, like live classes, industry projects, mock interviews, personal mentoring. So they have courses like full stack development, and they have specific batches for women and for working professionals. You can see the mentors are from top companies like Google, Microsoft, Adobe, Amazon, uh, and they have recently started this Launchpad IDE. So guys, I really love this IDE. Let me show you. So the user interface is really nice. It's very easy to use. And so we are here at the Launchpad and we will go to the playground. You can see they have a project playground, a markup playground, algorithm playground. So I am mostly using algorithm playground. So you can see like it's very easy to categorize and save your code. Let me show you. So you can see this code I wrote 3 days back. So it's very easy to use. So give it a try. Link will be present in the description. Let's take an example from merge sort. So I am taking the same input arrays I took in bubble sort and selection sort. So please do check out those videos if you haven't checked them out till yet. So let's start with merge sort. So merge sort is a divide and conquer approach, right? So what does we mean by divide and conquer? Let's see by an example. So this is our array, right? 4, 3, 2, 1, right? So divide means we will divide this array in two halves. That is 4, 3 and 2, 1. And we will keep dividing it 4, 3, 2, 1. So now we have arrays with one element in them. So we cannot go further. Now what we have to do, what is the next step? We have to conquer them. That is, we have to merge them. So we have to merge these two subarrays. Now how we have to merge? So remember we are doing a sorting algorithm. So how we have to merge is we have to compare the values of these two elements, and whichever is lowest will come first and the largest will come second. And similarly for these two, one will come first, two will come second. Now we have to merge 3, 4 and 1, 2, right? So again we will compare the first element of these two sorted arrays, and 1 is less. Sorry about that. So now 1 is less, so 1 will come. Now we will compare 3 with 2. So 2 is less, 2 will come. Now we have, so this array is finished, right? So now we only have 3 and 4. So we will put them as it is, 3 and 4. Okay. So guys, now let's discuss the time complexity of merge sort. It's a quite complicated one, right? So हम ये एल्गोरिथम इम्प्लीमेंट करेंगे रिकर्सिव फंक्शन से, राइट? तब रिकर्सिव फंक्शन की इक्वेशन बनाते हैं, राइट? तो अगर हम इसको रिप्रेजेंट करते हैं टी एन की फॉर्म में, इस फंक्शन को, एन क्या है? साइज ऑफ इनपुट एरे. तो हम क्या कर रहे हैं, हम टी एन बाई टू, ये एन बाई टू में डिवाइड कर रहे हैं एरे को, राइट? एंड कितनी बार? 2 बार. सो 2 का फैक्टर यहाँ पे आ जाएगा, ठीक है? और हम यहाँ पे करते जा रहे हैं एन बाई टू में डिवाइड. फिर बाद में हम क्या कर रहे हैं? मर्ज कर रहे हैं, ठीक है? अब हमारे सॉल्यूशन में है मर्ज का पार्ट, राइट? अब मर्ज का कितना है कॉम्प्लेक्सिटी? बेसिकली इसके लिए हमें एक लीनियर लूप चलाना पड़ेगा जो ऑर्डर ऑफ एन बार चलेगा, बिकॉज हम हर एलिमेंट को उसकी क्वेश्चन में बचाना चाहते हैं एंड विल कंपेयर देम. सो ऑर्डर ऑफ एन एक लीनियर टाइम में हो जाएगा ये कंपैरिजन, राइट? सो दिस विल बी ऑर्डर ऑफ एन. So इसमें एक ऑर्डर ऑफ n का फैक्टर आ जाएगा. दिस इक्वेशन इज वेरी कॉमन. इसका टाइम कॉम्प्लेक्सिटी होता है n log n. So इसको निकालने के बहुत मेथड्स होते हैं. If you want me to go more in details, then let me know in the comment section. Let's declare our vector. Let's name it as numbers, vector of numbers, and size will be size of vector. Let's take input for our vector. And let's create a function for merge sort. So let's pass our merge sort here. So now guys, what we have to do is we have to divide this input numbers in two vectors, right? So this will be a recursive function, right? So let's define this recursive function for merge sort. And so like, let me tell you what would be the parameters. So merge sort recursive vector int numbers and int left and right, so that we know that which part of the array we are traversing. So left will be 0 and right will be nums dot size -1, because we need to sort the whole array, right? And since this is a recursive function, so like we discussed before, what should be the base condition of the recursive function? When there is only one element left in the input vector, right? So let's apply the condition and let's return when there was only one element left. Now let's divide the vector in two halves. So let's calculate middle. So it will be left plus right minus left by 2. So guys, I did this and not left this right by 2 because it will prevent us from function overloading, right? Because if integers are around 10 to the 9, then it will give us wrong result. So now let's divide it. So now we'll again call this and left and middle. So this function will sort the nums vector from left to middle index, and second half will be middle plus 1 and right. Okay. And now, so like after these function call will return here. So these two halves will be sorted, right? So now we have to merge these two halves, right? So let's create a function for this. Let's create a function for this merge. Int left, int right, middle is in between, and int right? So now what we have to do is, now we have to merge it. So since we need to compare and we will create a copy of these two halves, so we don't have to, like, if we modify the input array in place, then there will be some overlapping of values and it will not give us the correct result. So let's create two vectors for left array and right array. And left array will be middle minus left plus 1 size, because both middle and left element are included in this. And right array will be right minus middle, because middle element is not included in right array, right? So now let's copy it. So we'll start from left. I less than equals to middle, because middle element is also involved in I plus plus. And now we'll copy nums sorry, we have to copy nums array to left array. So it will be I minus left, because the left array is starting from 0 based, right? In this function, left array is local array, right? So guys, don't get confused by array. Its name is vector. Okay, and similar thing we will do for right vector, right? So this will start from middle plus 1, because middle element is not involved. And right vector will be num. So yeah, so now we have copied we have filled the values in the vectors. Now what we have to do is we have to compare. So these two vectors are sorted, right? Left vector and right vector. So now we have to compare the values in this vector and put it at the right place in the nums, right? Nums vector, our input vector. So let's use iterators for uh, iterating left vector and right vector. So left iterator, right iterator, and we need an iterator for the input array, right? So let's say nums iterator. So it will start from left, because in this function we are considering the left right part of nums vector, right? So let's do this now. Let's traverse and compare. So left it is less than equal to less than, sorry, because it is zero based indexing. So I know it's a long function, guys, bear with me, it's about to complete only. So now we just have to compare left to a vector, sorry, and the right vector. So if left vector is smallest, then we will put this value in nums. Else we will put the right vector element in nums. Okay, now consider the case when one vector is finished, right? So in that case we just need to put the other vector value in the nums, in the output vector, that is nums, right? So let's say right vector is finished, right? So we just have to put left vector values in the right vector, in the nums vector, sorry. And similarly, if if left vector is finished, then we have to put right vector values. Okay, so I think this is done. This is our merge function. It merges two sorted halves, right? So now let's see. Okay, so there's no compilation error. So now let's give the output and see. So now let's give the input and see the output. Oh, sorry, we have to print the output also. So let's write a print vector function quickly. So it will be like void print vector int nums. So now let's run this. Okay, so it is not sorted. Let's quickly check out what is the error. So we pass the nums vector in the merge sort function. Okay, so we have to pass the vector by reference, because if we don't, then the original nums vector will not change, and that's why we were seeing 5, 4, 3, 2, 1. So let's check again. So yes, it's working. So now let's go to the assignment. So let's reset it. So we have this function. Let's copy our function here. So let's copy all these functions here. Okay, let us give them a little indentation. Yeah. So now let's call merge sort recursion from the sorting function. So let's hope for the best. I'm running it. So there's some compilation error. Something is wrong. Okay, so the error is non-void function does not return a value. So we have to return nonce here. Okay. Okay, so now our sample test cases are passing. Let's try to submit it. Okay, so it worked.